Welcome back to the flipped classroom. Our topic today is logarithmic equations, and this just happens to be one of my favorite things we do all year. Now, before we dive right into the equations, there's a few things that go along with these log equations. First and foremost are the log properties. You have to have these down pretty well pat in order to solve these equations. So let's just review them in our notebook here. Multiplication separates my logs into addition. Division separates my logs into subtraction. And there's that power rule that we've used quite a bit. When I take a log of something with a power, it can come down in front. So these log properties, like I said, are going to play a big part in solving these equations. Now, before I even get in on how to solve a log equation, I just want to talk about our domain. All right, and we've looked at the graph of logs versus exponentials, so let's kind of review a logarithmic graph. Okay, we should have a nice asymptote this way. Passes through the point of 1, 0. Now, you'll notice the domain here, the important part. Our domain values have to be greater than 0. All right, because there's an asymptote at x equals 0. Got this nice horizontal or vertical asymptote, and these values in this graph are all bigger than 0. Notice I don't have any x values that are negative over here. All of the x values are bigger than 0. Now, can it equal 0? And of course that's a no, because that's exactly where my asymptote is. So it's very important to understand that our domain has to strictly be greater than 0. So if I gave you the ln of x plus 2, and I told you x equals 8, is that a legal number to have for an answer? Well, if I say that's the ln of 8 plus 2, do I get a number in the domain? Do I get a number greater than 0? Well, in fact, the ln of 10 is greater than 0, so that checks. 8 would be a good answer here. What if I said x equals negative 4? I'll plug it in. I would get the ln of negative 4 plus 2, which is negative 2. Am I allowed to have a negative in my ln? Well, if I look at my graph even, if I go to negative 2, there's not even a graph there. So in this case, I would reject that answer. Okay? So we've got to be careful in our checks here. And when I say check, we're really just plugging it back in here to see if our value is legal or not. Let me throw one more at you. If I said negative 2, and I plug that in, I would get negative 2 plus 2, which of course is 0. And some people fall for that bear trap because 0 is not negative, so it's clearly not over here. But remember, that's where my asymptote is sitting. So I couldn't use 0 as an answer either in this equation. And we'll do some more checking after we solve a few equations, but just a little heads up there. Whatever's in these parentheses needs to be a positive number, greater than 0. So let's go ahead and we're going to jot down some steps to solving log equations or logarithmic equations. Step number 1, isolate the logarithmic expression. And we've used this word a million times. We used it last night in our video. We want to get the log by itself. And to do this, we might have to condense something. Step 2 is to convert to exponential form. And step 3, solve for the variable. All right, so here we go. Question 1. We're going to dive right in. 3 log of x plus 4 equals 6. All right, so I'm just going to run through my steps. Isolate the logarithm expression. So I need to get the log by itself. Well, who's in front of it? The 3. So I'm simply just going to divide both sides by 3 to get rid of it. And I'll get log of x plus 4 equals 2. Okay, so step 1, done. Got the log expression by itself. Step 2, convert to exponential form. Okay, so I'm in log form, and I know that because I see a log. I just need to convert it to exponential. Now, what's not staring right at me is the base. So think back to what we've talked about. If the base isn't labeled for, and you have a common log, that has a base of 10. Now, in case you forget, if you just look at your calculator, the common log button, right above it in blue, should be the number 10, to kind of jog your memory there. All right, so now I just have to convert. And we should have drawn some arrows, and that'll help us. Start by circling your base. You're always going to start there. You're going outside and then inside here. So we're going to say this is 10 squared equals the x plus 4. Okay, hopefully that's a little review for you there. Now at this point, we're just going to do some basic math here and solve for x. 10 squared is 100 equals x plus 4, so x equals 96. All right, now I do have to check, okay, and I'm going to reject anything that's not in my domain. So I'm going to go back here and I'm going to say 3 log of 96 plus 4. 96 plus 4 is 100. And if I picture my log graph, is it okay to take the log of 100? Sure, log of 100 is going to be way out here. There's a graph there. Definitely works. And you can verify this in your calculator. Remember when you check, you always go back to the original problem. And if we type that in, we should get a 6. All right, moving right along. Question 2, the ln of x equals 4. So running through my steps, isolate the logarithm expression. Already by itself, we're in great shape. This ln is by itself. Step 2, convert to exponential form. So again, I'm kind of in a jam. I don't see the base that's supposed to be there. So that's implying that I should probably know what it is. Now, if common log had a base of 10, if you recall, natural log has a base of, hopefully you've guessed it, e. And again, if you forget, look at your calculator where you find the natural log button and write in blue or green or whatever color above that ln button, you should see an e. So once I've identified it, I just need to convert to exponential. Okay, so remember, if you make the little diagram for yourself, it'll be pretty straightforward. Start with your base, go outside, and then back inside. E to the 4 equals x. And my goodness, this might seem weird, but we've just solved for x. We have x by itself. So my answer is e to the 4th. Quick check, ln of e to the 4th equals e to the 4th. And if you check both sides, I believe it does check. All right, example 3. 2 log base 5 of x plus 1 equals 2. All right, run down through the steps. Isolate the logarithmic expression. I need to get this thing by itself. Okay, so this 2 is in my way. To get rid of that 2, I'm going to divide both sides by 2. So I've got log base 5, x plus 1 equals 1. All right, step 2. Convert from log form to exponential. And remember, I know I'm in log form because I see the term log. Now this has a base, so that's even nice. I think if you always draw that diagram in, it's hard to screw up, so start with your base to the outside and then back to the inside. So 5 to the 1st equals x plus 1. Well, 5 to the 1st is 5 equals x plus 1. Subtract my 1, and hopefully you've got x equals 4. Okay? Now again, you can check by typing this in the calculator, but you have to be real careful with that base 5. So here's what we would prefer. When you go back and plug that value into x, okay, remember, it cannot be 0 or a negative. All right, I need this number to be greater than 0. So you'll notice 4 plus 1 is 5. 5 is greater than 0. That's telling me this is going to check, as long as all my math was right. Okay, I need this number to be greater than 0. Okay, time to make these a little more exciting. The ln of 2x minus 3 plus the ln of x minus 4 equals the ln of 2x squared plus 11. Whew, that was a mouthful. All right, so on step number 1 there, where our goal was to get the ln by itself, we said in parentheses there that we might have to condense. So you'll notice you always want to make sure you have one ln on each side. On this side I have 2, so let's go ahead and put some brackets there, and I want you to write condense. All right, we have to condense into 1 log. So this is where those log properties come in. Notice, you'll see a plus sign here. And when I see a plus between 2 logarithms, that tells me these 2 really came from, hopefully you've guessed it, multiplication. So I'm going to rewrite this as the ln of 2x minus 3 times x plus 4. Okay, this side only has 1 natural log, so I'm just going to leave it alone. All right, so let me run through what I did again. I need to condense these two logs into one log. So I said, addition came from multiplication, so I'm just going to rewrite them by multiplying them next to each other and have only one log here. Now, the beautiful part about balancing equations is if you have something that's the same on both sides, they cancel each other out. So since I have one ln here and one ln here, I'm going to zap those out. So I actually get, when I FOIL this out, 2x squared. If I add my 8 minus 3 should be plus 5x minus 12 equals 2x squared plus 11. Again, I'm going to set it equal to 0 on one side, so I'm going to subtract the 2x squared, subtract the 11, get 5x minus 23 equals 0. Add my 23, solve for x, so I get x equals 23 over 5. Now, they don't always have to turn out to be beautiful whole numbers. That's okay. So we'll take what we get, and we get x equals 23 over 5. Okay, now remember, you gotta check that answer because you cannot take the log or natural log of a negative number. So basically, I'm gonna plug my 23 over 5 in here. Oops, 23 over 5. And my goal is to make sure this number is greater than 0 and a positive number. So when I type in my 23 over 5 times 2 minus 3, I get 6.2. And taking the log of 6.2 is perfectly legal. Has to be greater than 0. When I put my 23 over 5 plus 4 in here, I get a number of 8.6. 8.6 greater than 0 definitely works so far. And remember, I just got to check in every x here. And when I plug it in this one, I get 53.32, which again is greater than 0. So I know that 23 over 5 is going to check. All right, number 5. Log base 2 of 8x minus log base 2 of x squared minus 1 equals log base 2 of 3. All right, so running through those steps. The first side I need to condense into one log. All right, so I'm going to say that's log base 2. Now I have to decide, what am I going to do with these two things? Well, this symbol right here should give it away. So based off my properties, when I see subtraction, I should know by now that came from division. So I'm going to rewrite this as 8x divided by x squared minus 1 equals log base 2 of 3. Okay. Now I have that nice balanced equation again. I've got a log base 2 here and a log base 2 here. So we can easily cancel those two out. So I have 8x over x squared minus 1 equals, and remember, fractions are actually easier. I'm going to call this 3 over 1. All right, at this point, if I have two fractions equal to each other, just a nice easy cross multiply. I get 8x equals 3x squared minus 3. Hopefully seeing that square term in your head triggers you to set this equation equal to 0. 3x squared minus 8x minus 3 equals 0. Now I know nobody loves guess and check, but this guess and check isn't too bad. Go ahead and try it on your own, see if you get the same thing here. And what I said by nice is that you only have one option for 3x squared. You've got to use 3x and x. And you only have one option for 3. You've got to use 3 and 3. I'm sorry, 3 and 1. Now I just have to decide where my 3 and 1 go. And I believe they go here. And I'll do a quick check. That's an x. That's a 9. Together, I can get a negative 8 by making the 9 negative and the 1 positive. And as I go through and solve on this side, x minus 3 equals 0, so x equals 3. And I get my 3x plus 1 equals 0, so x equals negative 1/3. All right, now remember, I'm not done there. Don't go ahead and jump and circle multiple choice answers. We need to go back and check. All right, so I'm going to check my answers, each answer separately, into the original equation. And again, I'm trusting my math is right. I'm just checking to see whether these answers fall within the domain. So to check negative 1/3, I'm just taking that number and plugging it into x here. Well, 8 times negative 1/3 is going to get me a negative number. And am I allowed to take a log of a negative number? Well, of course the answer is no. So I'm going to reject the negative 1/3 right off the bat. Okay, I don't need to check any further in these other equations because I already know it failed in this one. So I'm going to do the same thing with the answer 3 that I got. I'm going to check my 3. When I plug 3 into here, 8 times 3 is 24. That's perfectly legal. When I plug 3 into here, 3 squared is 9 minus 1 is 8. That's perfectly legal. Their number's bigger than 0. There's no place else to check. So 3 is going to be my only solution. All right, well, we've got 2 more to go, and I've saved the best 2 for last here. So number 6, log base 8 of x minus 6 plus log base 8 of x plus 6 equals 2. All right, same steps. I need to condense this into 1 log. All right, so I'm going to start her off with log base 8. And I'm going to say, all right, where did this plus sign tells me these 2 operations come from? Multiplication. So I've got x minus 6 times x plus 6 equals 2. Now you'll notice this is a little unlike the other 2 that we previously did. This log base 8 cannot cancel with anything over here. It's not balanced. This side does not have a log base 8. All right, so I'm going to keep cleaning this. Oopsie, what did I do? I'm going to keep cleaning this up and say this is x squared minus 36 when I FOIL all that out equals 2. All right, so at this point, I'm just going to go back to the previous style I was doing, the first, 2 or 3 examples there, and I'm going to convert to exponential form. And again, draw a circle around your base and make your arrows if you're stuck. Convert to exponential form. So I've got 8 squared equals x squared minus 36. 64 equals x squared minus 36. So I see a squared I'm setting here equal to 0. I get x squared minus 100. See some dots there. Factoring. I get x equals negative 10 and x equals positive 10. Last up, of course, just don't forget to check. So I'm going to start with x equals negative 10. And I scrolled back a little here to compare this to the original. Negative 10 back right into here. That's negative 10 minus 6 gets me, you've got it, a negative number. This guy's getting rejected. I'm going to check positive 10. Okay, so I'm going to plug this into my x value here. 10 minus 6 is a 4. It's legal to take the log of 4. 10 plus 6 is 16. It's legal to take the log of a positive 16. So my only solution is going to be x equals 10. All right, well, we've made it to our last example for the night on solving log equations. If you're feeling comfortable, go for it on your own and check with mine. Hopefully, we're kind of on the same page here. So again, I'm going to say I need to condense this one side into 1 logarithm. All right, and then I just have to make that wise decision. Where did this come from when I see subtraction? Hopefully you're shouting out division. Equals 1. Now, do you have to condense or kill? And remember, you can only kill the logs if you see the same thing on each side, a balanced equation. So hopefully you don't see that, and we're going to convert. So it should be 4 to the first equals this junk. 4 to the first equals x squared plus 3x over the x plus 5. 4 to the first, very nice, is just 4. And remember, make them both fractions. That will be easier mathematically for you. Quick cross multiply. I've got 4x plus 20 equals x squared plus 3x. Hopefully, again, that squared is triggering you to set your equation equal to 0. Factor, remember you're adding and multiplying. So I'm thinking 5 and 4. If I want a negative, that's going to be negative positive. So I get x equals 5 and x equals negative 4. And lastly, don't forget the big bad check. We've got to check each number separately. So let me start with the 5. Remember, I'm plugging it into this section here. So 5 squared plus 3 times 5 is 40. And that's legal. Log of 40 is perfectly fine. It's greater than 0. And when I plug it in here, 5 plus 5 is 10, which is 100% legal as well. So I know 5 checks. I'm going to do the same thing with the negative 4. Whoops. When I plug negative 4 into x squared plus 3x, 16 minus 12 gets me a 4, so that checks there. And negative 4 plus 5 is a 1, so that checks there. So in fact, actually, both of these check. So my solution is negative 4 and 5. Okay, so just because this value is negative doesn't mean you actually reject it. Make sure you check it, that you get a number greater than 0. Well, hopefully you enjoy these log equations, and we look forward to seeing you tomorrow.